using the candidate elimination algorithm. This is one of the popular approach in the machine learning technique where we try to learn a concept by finding the set of consistent hypotheses by providing with the training examples. So we can observe here there are four different examples are there with the attributes that is sky, air temperature, humidity, wind, water, forecast, and the concept over here is enjoy sport. So with these attributes, are we able to play the sport or we can enjoy the sport or not? And we have to observe here there are two combinations of the concept that is the with the positive examples as well as negative examples. Wherever we encounter the attribute value with respect to the concept enjoy sport as yes as the positive examples and no as the negative examples. So according to the candidate elimination algorithms, we have to set the boundaries. So what is this boundary? There are two boundaries. One is the specific boundary, another one is the general boundary. So here, once we set the specific boundary, it is related to the number of attributes that we are observed in the training example. So in this case, so there are totally 6 attributes are there. So that is why we are using the 6 null symbols here. And then similarly, the comma separated one. Similarly, the generic boundary comprises of 6 question mark symbols. The question mark represents, it can be replaced with any attribute value. So next what we are going to do, we check the training example and check for the whether it is a positive or negative example. So we can observe here in the training set, in the first example, the outcome of the enjoy sport is yes, that is nothing but the positive example. So since it is a positive outcome, then what we have to do, we have to check the generic boundary, which consists of all the question mark symbols for attributes. It can represent what all the attributes of first example, and also the outcome is positive. So it is consistent. So we are not modifying the G naught because it is able to what represent all the what attributes value. So now what we have to do, we have to check for the specific boundary where it is not matched with the first training example. That is not consistent. Why? Because it is not representing the any attribute value. So what we have to do, so we have to change the specific boundary with the attribute value. So we can observe here in the next iteration. So we are replacing the what all the 5 symbols with the actual attribute values that is related to the first training example, sunny, warm, normal, strong, warm, and same. And our general hypothesis that is retained as it is. So next what we have to do, so we have to go to the next training example where the outcome is positive and we have to check for the generic boundary which is consistent with the second example. So we can observe in the data set and in the second case also with the outcome as yes, that is the positive example. So what we have to do, so we have to check for the generic boundary and then we have to see is there any inconsistency. Then what we supposed to do, then we have to update, because in this case what is happening, it is consistent with the example because the question mark is matched with the what all the attributes. So what we supposed to do, so we are not modifying the what the G1, that is the generic hypothesis, we are not modifying, that is the boundary which comprises of the hypothesis. So this boundary is not get updated. So what we supposed to do, we are going to update the specific boundary. So we can observe here. So check for the specific boundary which attribute values does not match with S1. So if there is no match, what we supposed to do, so that we have to replace with the question mark and we have to update the S1 boundary. So we can observe here. So we have to find a match. See, we can observe the first attribute value as sunny, and we can observe here. So here in the training example, again, it is sunny. So then there is no replacement. And in here, the second attribute value is warm. And we can see here warm is there again. And here it is high. And here it is normal. So it is not matched. So now what we supposed to do? So we are replacing this by the question mark. So next what we are going to do? So we are comparing the next value, that is the strong. And here it is strong. So no change. And we can observe here it is warm. and here it is warm, no change, and here it is same, and here again it is same. So only this particular attribute value that is modified, that is we are replacing this normal by the question mark so that it can represent the values, that is the normal, it is able to represent the normal as well as it is able to represent the high value. So in this case normal, we are that is we can see the change with the another attribute value, that is with the attribute value high, so we are representing with the question mark. So now what we are going to do, we can observe in the specific boundary. So we have added the question mark and the generic boundary we have retained as it is. So next very important aspect is, so when we encounter a negative example, so then what we supposed to do? First we go to the specific boundary and check the hypothesis which is consistent or not. So we can observe here. So there is a chance like that as sunny. You can observe here that as sunny, that is there is a different attribute value here, that is rainy, and we can see here that is with the rainy, and you can observe here there is a no match, and there is a difference is there, and you can also observe here since it is not a positive example, so it is negative examples. So what we supposed to do, so we go to the what the generic boundary. So the generic boundary has to be updated, and we can observe here. So we are not actually what considering the specific boundary. So we are now modifying the generic boundary. So now what we have to do according to the algorithm, whenever it encounter the negative training example, so we are updating the generic boundary and we are retaining the specific boundary as it is. So we can observe here. So when this example compared to the hypothesis in the generic boundary and there is a match, but the outcome should be a positive. But here in this case, it is negative, so it is inconsistent. So we should write all the hypothesis till now. So what we are going to do, so we have to consider the what? The question mark in the generic hypothesis, and each question mark has to be considered to write the consistent hypothesis where the opposite value for the negative training example has to be considered. So we can understand this in a step by step. So we can observe here. So with the generic boundary, all our question marks are there. So now the first question mark, please observe here. So what we are doing, so this attribute that is we are replacing, we can observe here. So there is a rainy, that is we can observe here as a training example attribute value here, the third one. So this rainy has to be replaced. We can observe here that is replaced by sunny, and then we are writing remaining all the question mark as it is. So we are updating the generic boundary. So this is the first hypothesis. And for the second question mark, so we are observing here. So we are retaining the first question mark as it is. For the second question mark, we are replacing the cold attribute value with the warm. That is opposite of cold, that is warm, and remaining all are question mark. So we are writing it as it is. And again, we go to the what? The third question mark. So we are observing here in the third question mark, we observed here in the training examples, we have the value attribute value as high. So that we are replacing, that is its opposite is normal. So we can see it in the data set. So we can see here opposite of this, you can see the high, that is the normal. And similarly for cold, it is warm. And then for rainy, it is sunny. So we can discuss the different case studies to understand how actually the algorithm is going to work in order to find all the hypotheses which are consistent with the training examples. So next you can observe here. So in this case, so there is no opposite attribute value. All are same. So in this case, what we are going to do, so we are not writing any hypothesis for this. So there is no opposite value. And again, we can observe here. So for the fifth question mark, so we can observe here. So that can be, you can see here, there is a warm attribute value. So that is replaced by cool. So we can go with the data set. So there is a opposite value cool. So we are writing that here cool. And then we can see the last question mark. Okay. So, and for this last question mark, see, we have written this already. So there is a last question mark is there, this one. So we can relate here. So we are representing all the other attributes, that is with the question mark in the hypothesis, and the opposite of what the change, and we are writing that as same. So we can refer it to the data set. So there is the same. So we can see here the change, that is opposite. For change, again, it is same. So in the negative example, we got the change as the attribute value. So its opposite is what? Same. So that has to be updated. So we can see here we have written. So altogether we have written. So 1, 2, then 3, 4, around 5 hypotheses. So all the hypotheses are written. Then what we have to do? Then we check for consistency with the training examples till now. So please observe here. So till now, it is very important. Till now, we have encountered only the 3 examples. Okay, so now first we have to take the first hypothesis, that is sunny, and with all question mark. So the first example is consistent. Why the first example is consistent? So when we take this attribute, so we can observe here, so it matched with this sunny and sunny, and all the other attributes are matched because there is a question mark. And we have to also observe here, so when it is consistent, when it is matched, and all are with the question marks, all the attribute values are matched, and there is a outcome is what? Positive. So when there is a match, outcome is positive, then we are going to say it as what? It is consistent with the training example. Similarly, the second example is also what? Consistent with this hypothesis. So now we go to the second example, again sunny, and all the attribute values we can observe here, that is matched because question mark represent what? Any attribute value. So and the outcome is there is a match, and the outcome is yes. So again, so we can say what? The hypothesis is consistent with the second training examples also. So next what we supposed to do? So next we go to the third example. So here it is very important. So in the third example, so when we say it is consistent or not consistent, so we can observe here there is no match. So for sunny, there is a opposite training. So when there is no match, and then the outcome, that is nothing but what our target label is also has the value no. So when there is no match, there is a attribute value no as a enjoy sport. So no match, then no. So it indicate what? It is consistent with the what? Negative examples also. So now what we are going to do? So this hypothesis is consistent. That is especially this hypothesis, it is consistent with what? All the training examples till now. That is training example 1, 2, and then 3. So like that, what we have to do? So we have to observe the second hypothesis, that is this hypothesis, question mark, worm, and all the question marks. So please observe here, question mark, and then worm, and then all question mark. Similarly, how we have compared the first hypothesis. So we can observe here, it is consistent with the first example. So we can see it is consistent, sunny, warm. So there is a question mark, it is matched, warm and warm, it is matched, and all the question marks, that is matched. So the outcome is yes. So that is consistent with the first example. And we can see that in the second example, so the first attribute value, there it is in the hypothesis question mark, and here it is sunny, it is matched, warm and warm, it is matched. So since it is question marks, all are matched, and the outcome is yes, and is a positive example. So now we can say it is matched with all the values, and the outcome is yes, and so it is consistent. So next thing we can observe here, the third example. So we can observe here the second attribute value, that is we are considering the warm, and the opposite is cold, and there is no match because question mark represent all these values, but here there is a no match, and also the outcome is no, that is it's a negative example. So it is consistent with the what? All the 3 training examples, that is 1, 2, and then 3. So the second hypothesis is also what? The consistent. We can see first example, second example, it is consistent, and there is no match, and the outcome is no. So it is also consistent with the third example. So now we consider the what? The third hypothesis, then question mark, and then normal, and all the remaining question marks. So now what we have to do? We go to the data set now. So with the training examples. So there we can see here in the first case, question mark, and normal, there is a match. And again, the question mark, there is a match here. So the outcome is positive, that is yes. Yes, it is consistent with the example number 1. And we can refer to the next second example. So question mark is, it can be matched with here. Again, question mark, it is matched. But here we can observe here the attribute value is high. but in the hypothesis, we have the value as normal. So there is no match. If there is a no match, then it is consistent. Then the outcome should be what? The negative. So here actually no match, but the outcome is positive. That is yes. So we can say it is not consistent with the second example. So we are writing, we can observe here. So there is no match, but it is not consistent with the second example. So now what we supposed to do? The third example, again, we can take it here. So go to the third example again. So there is a mismatch, that is the normal and then high. So we have the in the hypothesis normal and high. There is no match and we can say it is no. That is the negative example. So it is consistent with the negative example. So what is the purpose of candidate elimination algorithm? We have to find a consistent hypothesis. That is nothing but what? It is consistent with all the training examples. So in this case, it is not consistent with the second example. So we are not considering this particular hypothesis, that is question mark, normal, and all the question marks. So we are not considering. So now similarly, we can go with the another case, that is all the question marks, and then there is another attribute value cool, and then question mark. So we can go to the data set related to this with the training example. So now we go to the first example. We can see here. So in this case, what happens? We can observe here the this is not we have considered with the attribute value, because we have all are same, so we have not considered. So we are considering this particular question mark. And then here guys, what we have written, the opposite of this, that is the negative example, that is warm, we have written cool. So in this case, we can see here for cool, the opposite is that is, we can observe here warm is there. So we can go to the hypothesis and you can see there is a cool, and here it is warm, so there is no match. And when there is a no match, if it is consistent, then should be no, here no, what you can say, the outcome should be there. So when there is no match but there is outcome as yes, so it is not consistent with the first example. Similarly again it repeats here. So question mark matches all with this, and here there is no match because here it is warm, the attribute value is cool in the hypothesis. So there is no match, but the outcome is yes. So it is not consistent with the second example also. And then what about the third example? And again, here there is warm, and in the hypothesis we have cool. So then there is no match and the outcome is no. So in this case, what happens? So it has no match. So only it is consistent with the third example, and it is not consistent with the first and second example. So we are not considering this hypothesis. So we have to find the hypothesis which is consistent with the training example. Still no, because still we have encountered the first occurrence of the what, the negative example. So till now these hypotheses are not consistent. So next we focus on the what, the next hypothesis, all question marks and then same. So now what we have to do, we have to take this hypothesis and then we are actually started comparing, and we can see here the question mark matches with what, all the attributes, and then same, yes there is a match and the outcome is yes. So now, so there is a match, outcome is yes, then we say it is consistent. And we can go to the second training example. So all the question marks are matched, outcome is, you can say there is a match, that is same and same, and the outcome is yes. Yes, it is consistent with the second training example. And then we go to the third example. So in this case, there is a no match, that is since same is there in the hypothesis and change is here. So when there is no match and the outcome is no, then we can say it is consistent with the what, this negative example. So we are able to what, observe here, it is consistent with the first, second, as well as with the what, that is third training example. So we are selecting this hypothesis. So now altogether, out of the hypothesis 1, 2, 3, and 4 and 5. So we have able to select only the 3 hypotheses. So we remove these 2 inconsistent hypotheses with the training example. So now, so we have updated our generic boundary. So with these 3 hypotheses, so we can observe here. So these are the 3 hypotheses. It is consistent with the what training examples till now, and we can observe here. So in the specific boundary, that is we have written already, that is sunny, warm, question mark, strong, warm, and then same. So now what we are going to do, so next we observe the training example again, and we can see here we have encountered the positive training example. So now guys, whenever we observe the positive training example, so we are updating the specific boundary. And also what we are going to do, so in the generic boundary, again we are going to filter the hypotheses which are not consistent with the training example. So what we are going to do, so we can observe here. So we can go to this iteration. You can see here that is the last example is positive. So we go to the generic boundary and check for consistency. So we will see that is with the specific and generic boundary, what are the things has to be updated. So we can check for this. And then we take the first attribute value sunny, and then all the question marks, it is matched, and the outcome is positive. Yes, we are retaining it as consistent. So we can see here with the data set. So this is the data sets. It is sunny, and the question mark matched with all these attributes, and the outcome is yes, it is consistent. And then next, what we have to observe, next hypothesis is this one, that is a question mark, warm, and all are question mark. So again, we go here, question mark, warm, all are question mark, correct? So then it is matched. So we can observe here. So in this case, when we go here, so it is matched, consistent, and again it is matched, correct? So outcome is positive. And then when we say that when this question mark same is not matched with the fourth example, so we can observe here, but the outcome is positive, so it is inconsistent. So when we observe this hypothesis, when we go to the training example, so we can observe here sunny, warm, these all there is a match. And then here we can observe here, so there is no match. So we can see here, so there is no match here. So that is with the fourth example, so that is the same. And we can observe here, and there is a change. So there is no match, and the outcome is again it is positive here. But when there is no match, we are expecting what negative here in order to consider it as consistent hypothesis. So it is not consistent. So we're not considering this particular hypothesis. So now what we are going to do, so we have selected only two hypotheses, that is in the generic boundary, and then one hypothesis that is with the specific boundary. So now what we have to do, so we have to update the specific boundary because generic we have already selected. So what we have to do, we have to check for the specific boundary and check for the attributes. And if the attribute not matches, we have to change this with the question mark. And we can see here sunny, that is this specific boundary we can take, that is sunny, warm, question mark. So we can see here that is sunny, one second, sunny, warm, and this is high, question mark. Then strong, cool, change is there. So what we will do, so we come here, then we can see strong, cool, and then change. So there is a difference. So what we are going to do, so we are replacing there with the question mark. So now we have updated the specific boundary, updated the generic boundary. So according to the candidate elimination algorithm, so what we have to find out, we have to find the version space which comprises of what? All the hypotheses which are consistent with the training example. So we got this boundary. So we can observe here, since there is more than one hypothesis, so what we have to do, so there are more possibilities can be considered. So here there is specific boundary, only one hypothesis is there, but in the generic boundary, there are two hypotheses. So now what we have to do, so we have to find the hypothesis intermediate with these two boundaries, and then we are observing all the hypotheses which are consistent. So now we can observe here, so we have to do the matching, that is with the hypothesis that is from the specific boundary, and then one hypothesis in the generic boundary. And we can see here sunny, warm, question mark, and then strong, and then question mark, question mark. So please observe here this carefully. So what we are written, so we have written this S4 as it is, and then this has to be matched with the first hypothesis in the generic boundary. And you can see here, so there is a match, sunny and then sunny, and there is a question mark and then warm. So there is a first mismatch. So we have to observe the first mismatch and warm. So when there is a first mismatch, so then what we are going to do, so we are writing that new hypothesis. So we can observe here sunny, then warm, and then we are writing all these question marks. So you can observe here the next mismatch we have to see, that is the question mark. And what we have to do, so we are observing the strong value, that is the consideration, and then we are writing the new hypothesis. And we can see here there is a next mismatch. So we can see here that is with this sunny, that is same as it is, and then question mark. And we have this case we have been already considered. So then a question mark and then question mark. So here question mark and question mark. And then we can see there is a first mismatch, again strong. So we have considered this strong, and then question mark, question mark. So first case we have already written. So now there is a second mismatch. So we have written new hypothesis. So we can see here. So this is the what? The new one. So we can see sunny, warm, question mark, strong, question mark, question mark. And you can observe here, then question mark, warm, all question mark, warm, all question mark. So we can see here. So this, okay, so there is a first mismatch. So what we have to do, so we have to write the new hypothesis. So what we are doing, so first we have compared this hypothesis with this hypothesis. So now we have to compare this hypothesis in the specific boundary with this. So we can see here, so sunny and then question mark. So there is a mismatch. So what we are doing, sunny and question mark. So the first mismatch. So we are writing the new hypothesis. So what we are writing now, sunny, warm, and so we are writing all these question marks. But this hypothesis, what happens, this is already there in the what, in the consideration. So what we have to do, so we have to find out the next mismatch. So what is the next mismatch again? So we have question mark, warm, again question mark, and here we can observe here there is a question mark and here it is strong. So there is a second mismatch. So and we can see we have written here and then the remaining two question marks. So this is the new hypothesis. So now there are total number of hypothesis is 6. Okay, so now what we have to do, so we have to write the version space. So we can consider here, that is the in the generic specific boundary, sunny, warm, question mark, strong, and question mark. And then in the generic boundary we have two hypotheses, and then these are the what, the intermediate hypothesis. So altogether this 6 hypotheses represent the version space. And we can observe here this sunny, warm, and all these 4 question marks, that is the in this hypothesis, it is obtained by the specific boundary here, this hypothesis and this hypothesis. And similarly, this hypothesis we are able to write here with the combination of the specific boundary hypothesis and this hypothesis in the generic boundary. Similarly, so what we are observing, this intermediate hypothesis is the result of the comparison of what, the hypothesis here in the specific boundary and this hypothesis in the generic boundary. So there are totally 6 consistent hypothesis for the given training example. And this is the what we are able to find out with the help of candidate elimination algorithm.